Welcome everyone. Today we're going to be talking about how to use async, await, and task. Primarily we're going to be talking about some pitfalls that you can run into and how to avoid them. Because generally there's only one way to use them, and just try not to make these mistakes. If you are interested about how this concept actually works, go ahead and watch my previous video. I'm going to link it in the description, or maybe try to put it as an annotation if I can figure out or be bothered to do that one. We're also going to take a look at a WPF example at the end, just because it has that UI thread, the old important UI thread. And hopefully I can give you a mindset on how to think about these tasks when using them. So before we jump into these examples, let's primarily get it clear. If you did watch the previous video and you now have this image of a state machine that we're spawning constantly as soon as we put async in there, and all these states we're adding when we use await, and the task is this bridge between the state machine and your code. I want you to leave that all behind. The fact that it's a state machine and stuff like that is going to hinder your performance in terms of understanding it. It's going to give you a bunch of ideas that are not necessarily helpful. All you want to be thinking of a task is it's some work that needs to be completed. It doesn't matter what thread it's completed on, or even if it's started and ends on a different thread. You don't even need to know that. All you need to know is that it's some work that needs to be done. It's also known as a promise or a future in other programming languages. And to add to that, a task, it is what it sounds. It's a task, it's a promise, something that we need to do, and we need the result of whatever work that is. That's when we await on it. And all the magic that happens with a thread in the backgrounds, just don't worry about it. It's just nice to know what actually happens. So let's go ahead and take a look at the first example of avoiding the state machine. So this is probably a situation that you can find yourself in most often. Is you might get an interface which will ask you to implement a task or return some kind of a value from a task. But you don't necessarily need to do input-output operations. And by the way, I'm just going to diverge here real quick. The only times you really do want to create tasks and async await is when you do input-output. So that's communication with the database, your disk drive, SSD, the network card. And the database communication is kind of the network card. So it's interacting with an external source. So for me, an external source would be the computer. I press the button and I wait for it to start so I can go ahead and write code. For our application, the external source is going to be that network card, that disk drive, okay? And the disk drive can work separately from our application, so our thread doesn't block. But that's something I explained in the previous video. So yeah, the only time we want to use async task and await is when we do input-output operations. And the primary takeaway I want you to have is as soon as you put async, you spawn a state machine. Okay, so that's just to keep in mind. That's how we avoid creating a state machine. We avoid using async, okay? So coming back to the example where you have an interface and it has a task that it wants you to return from it, you will want to do something along the lines of this. So you might have some kind of a message, and I've seen people do this. So they will have hello world here, and they will try to return this message. And what it will do is it will give you an error, right? And it will say cannot implicitly convert, and you're like, oh, what's going on here, right? And the first reaction will be, oh, it's a task, so I have to use async. Okay, don't do this. As soon as you write task, you spawn a state machine. All right, it's extra code, it's extra logic, it's extra space that you're consuming in memory. Okay, it can be a micro optimization in some places, but avoid doing this. Okay. What you want to do is you want to use task from result, okay? And if you don't need to do it, you don't need to return anything. You can go ahead and say task.complete. Okay, I'm just gonna see on the end here as completed task. So it compiles. Okay, so here in both examples, we have the task completed. We have to implement a task, but we don't actually have to do any input output, so it's still sequential execution. To avoid the async await in this scenario is just to use task.fromResult or task.complete to initiate the completion of the task. Okay, and no state machine will be spawned there. It's just sequential execution at this point. Next thing is sometimes what will happen is, let's go ahead and put N here for network. You will have a client. It will be an HTTP client and what will happen is you will want to get some content from this client. So we get string async, and this is some site. Okay, and what you will do is you will want to return this content. Okay, and you will have to put async here in order to wait for this call. But one important thing here is that content is of type string. If we return the await here, it's going to be of type task string. Okay, it's the same type here. So you want to avoid creating this async value here when you return this content here. Okay, we're avoiding spawning a state machine, but just returning the task itself. Okay, you want to avoid storing it and returning it. There are going to be situations where you actually do want the content that we get. You want to, let's say, validate the content, right? Validate, we can replace it with something a little bit more generic, like do something with the content. Okay, and then we want to return the content. All right, so if we need the content specifically in this function, we then await on it. Okay, otherwise avoid using async and await here. You actually just want to go ahead and return the content straight away. Okay, so it's just something to catch yourself on doing this. Don't go out actively looking for it. You can do it at the start, but again, this can hinder your performance in terms of the actual work you're doing. What you actually want to do is be like, oh, I actually don't need to spawn a state machine here. Don't go looking through all your code trying to find it. Okay, and by the way, one thing that I'm going to be mentioning here that's not specific to avoiding the state machine is that as soon as you use async or even tasks, it will basically propagate through all your code. Your code is now bound to the task object. So what that means is that if your index page, you want to go ahead and grab the result of the input output operation, you will need to await on it, and you will need to turn this task. All right, don't be scared of doing this throughout your code. It is okay. At some point, you will need to spawn a state machine and await on it. Try to avoid doing it for as long as possible. Okay, don't sacrifice code readability for not spawning the state machine. Async await exists to improve code readability. Okay, that's its primary function. If you need to do something here with the content before returning it, do that. Okay, you want readability over the state machine, right? But when possible, avoid it, right? So that's the primary lesson here. Next thing is, let me actually go ahead and grab this. This is not going to be so visible in this example. This is why I will be using the WPF example, is when we will be using the configure await function on an async method, right? So we have configure await, and the only time you're going to be using it is to pass false into it, right? By default, it's true, and all it is, it means that we don't care to what thread this returns. So if you watch the previous video on async await, me explaining it, we've already seen that behavior of configure await false. So in here, it doesn't really matter. You're not going to see this prominent difference in .NET in web application. It's more going to be, it's going to be visible more in the WPF app. But essentially, the whole thing about this configure await is that we don't care that it returns to the same thread, right? So if we have thread ID 1, this should be thread ID 3, and if we don't call this should be thread ID 1 as well. Okay, so we're basically saying return to the same thread, but in a web app it doesn't matter, so you can just go ahead and add configure await as much as possible. So you want to be using configure await in a web application, and again, I'm going to run some code on WPF app to show you that you don't want to be doing that there, but this is okay to be using. And all this means, again, I'm just going to restate myself, is that we don't care what thread continues the execution of this function. Okay, if the result of this needs to return to the same thread, we don't care. When we say false, we say we don't care that the result of this comes back to the same function. All right, I repeat that myself a couple of times, but okay. So Next thing, don't async in constructor. All right, do not try to force calling asynchronous operations in your when you're constructing an object. That's absolutely, I think, one of the worst things you can do. Some people still teach it. They try to show you workarounds of this. Don't do it, please. What you will have is some object, and you will have a constructor. And I'm gonna say never do async here. Okay, it's just something you never want to do. Okay, what I'm gonna propose to you are two alternatives. Okay, so the first alternative is you're gonna have a some object factory, and this is then going to have a public async task some object that is going to return, and you're gonna call create. Okay, and then you can inject whatever services, HTTP client, into the constructor here, and when the service gets resolved, you can then call the asynchronous operation here and return your task from, or basically some new object. Okay, so this is essentially what you want to be doing. You either want to create a factory. If you have different ways in which you create the sum object, you probably want a factory. If there's only one way that you can create this object, you probably want an static function, right? So let's go ahead and create a static function. The signature is going to be the same here with a sync. Okay, so what you want to do is either use the static function if you can only create this object in one way. Use a factory if there is a variance in how you create this object, but you still need to do some kind of asynchronous operation. Okay, please do not put any asynchronous operations in the constructor. Do not use async void in order to accomplish it, and async void is probably a whole different topic. Just don't go there. Okay, if you're ever in a situation where you have to use async void, it's already too late. You've jeopardized your code, all that basically led you to this point. Kind of like go-to statements. If you're in a position where you need to use a go-to statement, it's either a very specific scenario or you jeopardize somewhere along the way. Okay, so the next one is probably more of an important one because I've seen this done, or a lot of people complain about this as well. Is, again, let's say we have some kind of asynchronous operation. So let me grab this. It's here. Here we don't want to block our thread. Okay, I don't know who does these, but some people do these. Let's go ahead, do the input output. So we take the task and we put it in here. And usually the only times you will be in a situation where you want to block the thread is when you haven't made the parent function a sync or a task. Okay, when you're not trying to wait on it. Let's do bad. Every documentation that says don't do this is bad. Okay, you just grab the result. Do not do this. Okay, this is probably one of the worst things you can do. Let's do another bad. Task wait. Okay, these are all blocking operations. The thread is gonna come here and it's gonna wait. So if your process has one core, your application is gonna halt. Okay, you won't be able to process more requests. Another bad. So you see this result here? There's a different way that you can do this. You can go ahead and call getAwaiter and get result. So this is also bad. You block the operation. All of these can be avoided by simply following the rule that your async await task is going to be propagated from your code and being okay with it, embracing it, and like, yeah, this is just the way you need to do asynchronous code and not to block your thread. Do not try to stop the propagation through your code by utilizing something like this. You will need to turn this async and actually await on the task. So solution is to propagate. I don't know how to spell propagate, but async await task through your code. Okay, and as I've said, all the three steps before, where you don't want to use it in your constructor, try to avoid state machines as you're going to be propagating your code in order not to block your threads. You just want to make sure that you're applying the previous lessons to minimize the damage of the state machine and memory consumption as much as possible and keeping performance. Because async await, although it does give you performance in terms of non-thread blocking, sequential execution is still much faster. But if you're worried about that sort of thing, you would be doing C++, C, or Rust programming. In C# world, we're worried about readability. So let's take a look at how this task can propagate throughout your application. So let's say if it starts somewhere in the middle, it's going to propagate all the way back to the beginning of your application, right? But if we take a look at the typical program CS file of a web app, it doesn't actually have any tasks in its main. So what we want to do is figure out how do we start a sort of a task collection or execution and basically still remain with a non-task main, right? So let's go ahead and do something along the lines of start app, kind of what it does here. And when I remember how to type again, right? So we will have to make this a static void as well, right? So we're just gonna call start app. And what we want to do now is we essentially have some collection function, which is just a while loop, which we can do to replicate the network server or a socket server, right? So we're just in one loop to go ahead and keep reading from the network driver, right? And then we're gonna process whatever we collect, except here we can do some network stuff in order to fetch something from the internet. Here we're gonna process this message, so we might do something with the database. And then if we find something interesting, let's go ahead and notify. And this is where we're gonna use task.run to do fire and forget, okay? So how can we kick off these two processes to run side by side? How they communicate between each other doesn't matter at this point. Let's just say that they are communicating between each other. We just haven't done the implementation yet. So these tasks are going to be running side by side. And let's say if collect blocks, process can then do whatever it needs to do. And if both are blocked, notify can be executed. And by the way, as I explained in the previous video, these do get run on different threads, and the more processes you have, these are gonna get run in parallel, okay? So in our startup, what we can do is we can go into task and call wait all. And for wait all, we would provide an array of tasks that we want to start. So we would kick off a couple of tasks. So let's go ahead and grab our collect task. And again, this is probably going to need to be static. Okay. We will put a semicolon here. Let's go ahead and call this static too. And we'll create a process loop as well. So we're going to have two loops running side by side. Again, I'm not going to execute this code. This is just a theory. And this does have a message. Don't really need this message here. Let's say that it's going to communicate through other means. Doesn't matter at this point. But if we want to kick off these two loops, we just go ahead and create a new array with collect and process. And these two loops are going to be running now side by side until both of them finish. But because we put them into loops, they're never going to get finished. And what can be done further is we can put them in try catches. And if they break, resume execution, right? But at this point, it's an implementation detail. One point is that when all of these tasks are finished, your application finishes and it sort of exits, okay? So it finishes, stops, no, it no longer runs, okay? And this is what you would do with awaiting on all tasks. Now let's say you have this as a task and this is no longer something that you want to return, so because this is going to be blocking execution, right? Let's go ahead and create a task that's going to be awaiting on a collection of tasks, right? And now we want to use when all, all right? So this is going to be returning a task, but what we're going to be supplying to it is this. And now, since we return a task, the way we would actually start the app, because if we execute this now, it's just going to finish straight away, right? And all the background threads are going to be killed as well. What we want is to actually get the awaiter here and get result. So this is how we would start the app. Let me copy this and comment out the older version. So this is how we would start this app in this case, but do keep in mind this is still something that we can await on. All right. So there are your two options to really execute different tasks, and you can and let's say you have your two main tasks you can run on the foreground thread, and then you have some kind of notification task that might send some notifications. And primarily what I wanted to say is, let's say when we process messages, if we do run into a condition when we want to notify someone, we don't really care when that task completes, we just want to complete it. Okay, so let's go ahead and say that we want to notify. Okay, and again, this is going to need to be static. Go ahead and say hi. Okay, so a simple message, and this is a fire and forget. One thing to note, if you have kicked off some fire and forget tasks and your application crashes, so you get past this point and your application finishes, any fire and forget tasks that haven't finished are going to be cancelled off and they're not actually going to be finished. So you could do something like store these tasks in a list somewhere or a stack, so once they're finished you pop them back off, and in case your application does crash you can await on them after here in your main as well. Okay, but again, this is more of an implementation detail. All that I want to showcase here is an important piece of functionality where we can await on multiple tasks by blocking, and this is okay, and this blocking is okay as long as it's in the main and it is used as a root of your propagation, okay, of the tasks. And then again, just being able to await on multiple tasks asynchronously, right? So this still returns a task that we can await on, and the fire and forget function. So that's pretty much all that I wanted to showcase here. So in this example, we're going to take a look at a WPF app, and primarily what I want to take a look at is this configure await false example, okay, and where the main thread begins and where the main thread ends, kind of thing. I mean, not by the main thread, I mean the UI thread, okay? So what I want to do is I want to just go ahead and add a button, all right, anywhere on there. Can I make it bigger? Bigger the button. I never really use WPF. I just know that this example can be shown through it. Next thing, I want a text box, and let's go ahead and for this text box, I'm gonna give it a name, just so we can grab it. And what should we call it? Test box. We'll call it test box. So double click on this button. I'm gonna get a little function here. Basically, what will happen if I click on this function? To my surprise, when I looked up how to do asynchronous tasks, it's basically the only way to do it is by doing async void on these buttons. And what I want to do is primarily how I did in my previous video, is just log the thread ID that I'm using while executing this task. So let's go ahead and make a private list of strings. So this is like my what's it called, thread log, and this is going to be a new list of string. So when I click on the button, what I want to do is I want to log that I am going to be doing step 1, and that the current thread managed ID will be a certain ID, okay? So once that's done, let's go ahead and grab the next step where we're gonna do some asynchronous operation. So we can go ahead and get some content from the internet. Again, I can just go ahead and make a private HTTP client. Let's make a client. So a new HTTP client. Okay, and just really simple. Let's do client get string async, and we're gonna call google.com. And this is the part where I'm actually gonna run the code in order to see this, and then we're gonna output hello world here. So again, this is just an example. We just want to see what will happen at different points where we use configure await, okay? So then we're gonna use this thread log. We're gonna thread log here. This is gonna be step 2, because we're gonna grab some text from this do function. and we're going to make sure we await on it to propagate the control of the thread. Okay, this is going to be step 4 because another place that I want to log is right after we get the content, and this is going to be step 3. So we're going to do step 1, step 2, step 3, then step 4 because we're awaiting here. And what I want to do is then I want to grab my test box. I'm going to grab the text and I just want to set the text here. So when I run the application, all it's going to do is it's going to fetch something from the internet, and it's just going to append the text of hello world instead of text box here. What I will also do is, not that, let's grab another button. Let's put it here, and this will be our log inspection button, right? Advanced concepts here, but we're gonna add another event, and all I'm gonna do here is I'm gonna say, give me my thread log, buddy. And I'm gonna put a breakpoint here just so I can inspect it, right? So let's go ahead and run this. Looks like I got an error. Let's see what's up. So I have build errors in a different application. Okay, so I want to run my WPF app, not my web app. So I was wondering where the error is coming from. Right, here's the text box. When I press this button, it's going to turn to hello world and populate the thread log. So let's go ahead and press it. We have the hello world here. Let's go ahead, press this button, and we're going to hit this breakpoint where we can look at the thread log. So all the steps are executed on the same thread, okay? And that's the UI thread. So thread 1 is the UI thread, right? So basically, where in the previous video you would see the example of the thread is basically gone off and done something else, and this has been done by a different task, right? Because you got to understand that the thread is constantly flooring by re-rendering the UI of the application here. What we can do, because this task is not necessarily returning to the UI thread, so what we can do here is we can actually configure it to false. Okay, so here you will be able to see what exactly it's doing. So let's go ahead, press the button. We'll take a look at the log now, and you will see that step number 3 is now executed on a different thread. And again, this is not so important for the web application. This is more important for the WPF application. But again, because when you're building a library, you don't want to be running your tasks on the UI thread. You want to be implementing configure await false. Okay, so your library doesn't work worse on WPF applications than it's doing on the web app applications. Okay, so this is only really useful if you're implementing libraries. So again, just to sum up, that the configure await is going to run this on a different thread, and once we return, if I stop this to remove all these windows, this step 3 is run on a different thread, and once it gets joined up back on the button click, since the thread that's going to interact with the UI here with the text box, it needs to be the same thread. Okay, so this is again step 4 is executed on the first thread. Let's go ahead and see if we try to configure false here. What do you think will happen? Right. Let's go ahead and run this. Press the button, and oh, exception. The calling thread cannot access this object because a different whatever. Okay. Let's see if we can take a look at the thread ID here. Oh, so no, will it let me? There a way? Okay, so we can see that the execution actually resumed on thread number 11 as well. And thread number 11 doesn't have access to the UI. So the application will crash there because the UI runs on thread 1, and that's where its state is kept. So thread number 11 doesn't know anything about the UI. So that's pretty much just summing up configure await, and probably the only place where async void should be used. But yeah, this will be it for this episode. Thanks for watching. If you enjoyed it, leave a like, subscribe. If you have any questions, leave a comment. If you have any other specific situations that you have used async await task and I haven't covered it, please go ahead and leave a comment, share the knowledge. I also stream on Sundays, on Wednesdays, and if you want updates for that, join my Discord channel. All the links are in the description. Hopefully, I'll see you in my other videos.